Let's suppose you're standing in a large empty room and you take the time to draw a big arrow on the ground. And you draw an arrow pointing forward in front of you, and you label that with a positive sign. And right where you stand, you draw a big 0 on the ground. And facing back behind you, you extend the line and indicate that behind you is in the negative direction. Now, if you move to the right, you can't move without having some velocity. You can move without having an acceleration, as in you can move at a steady speed. Assigning positive and negative values to describe how fast you're moving or how quickly you're accelerating might be a little bit off of what your intuition tells you. So you might think of a positive acceleration strictly meaning speeding up, and that a negative acceleration strictly means that you slow down. That's not exactly the case. So I provided 6 examples here. Actually, you're going to provide the examples, but I've offered 6 cases in which the velocity and acceleration can either be positive, negative, or 0. And I'll fill out the first couple and give you a chance to see if you can figure out the rest. So, is there a possible case where an object could have a positive velocity yet have 0 acceleration? So remember now, positives and negatives don't refer to increase or decrease. They just refer to agreement with your number line. So a positive velocity means moving forward. And 0 acceleration means you don't move forward any faster or slower. You just keep going at the same rate. So this just is moving forward with steady speed. So that was easy enough. Now, can you have a positive velocity and also a positive acceleration at the same time? So again, the positive velocity means moving forward. And the positive acceleration means moving forward while speeding up. Now, here's the thing. I didn't take that just at face value that positive always means speeding up. I'm thinking of it like this, and I'm getting a bit ahead of myself because we're really supposed to be studying kinematics, which is the study of motion without regard to the cause. But I don't mind mentioning that an acceleration requires some force. And so let's imagine that this person isn't just walking, but they're on roller skates. And so the reason they had a positive velocity is at some point in time somebody had pushed them from behind. So now they're drifting to the right with some speed. Okay, so we've got the moving forward part of it. Now, you're somewhere else in this room, and like a rodeo cowboy, you can swing a lasso and get a rope and have that rope end up around this person's waist. And now you're going to pull on that rope in an attempt to give a positive acceleration. So you apply a positive force with the rope, meaning the rope is going to extend this way and you're going to pull in the positive direction. And so if you did that, this person would definitely go faster and faster. Now, as a counter argument to that, let's, let me skip forward to case number 4, and I'm going to leave it up to you to provide an example for case number 3. Okay, so case number 4 is a negative velocity and a negative acceleration. Well, the negative velocity just means there has to be movement in the negative direction. Let me erase some of this. So we'll put our person back at the origin. Okay, yeah, negative velocity just means they're moving backwards. Oops, wrong spot. Okay, Now, negative acceleration, oh, that must mean moving backwards while slowing down, right? A negative acceleration means slow down. No. Negative acceleration doesn't necessarily mean slowing down. A negative acceleration means there was a force applied in the negative direction. That would be like wrapping a lasso around this person and then taking that rope and pulling it in the negative direction. Well, if somebody was already moving backwards and you pulled in the same direction, that person would speed up. So negatives for acceleration could mean speeding up, just as well as a positive acceleration could mean speeding up. Positive and negative refer to a direction on a number line. They don't refer to speed up or slow down. They don't refer to increase or decrease. So with that notion in mind, I leave it up to you to see if you can figure out an example that corresponds to cases 3, 5, and 6. If you're unsure, you can check with your classmates, ask them in person, ask them through Discord, or you can bring your questions to office hours, either in person or virtually, if that's the way we're working.